In our last video, we talked about differentiation rules, and we actually went through almost all of the rules that appear on in your textbook on page 283. The only rule we didn't talk about was a rule for f of x equals 1 over x. In this video, I want to talk about how to find an antiderivative formula for 1 over x, and we're going to start by graphing a function. Well, you might already be thinking, hey, 1 over x, that's not that hard to antidifferentiate because the derivative of the natural log is 1 over x. But I want to start by graphing the natural log of the absolute value of x. Well, we know the natural log of x would look something like this. And the natural log of the absolute value of x graph would look the same on the positive because absolute value doesn't change a positive number. But what we can do now is I can plug in negative values for x. The absolute value turns it into a positive, and I get the exact same y values but mirrored across the y-axis. That absolute value really created an even function. And so the idea here, if I take a value a, I plug it in and I get a y value that's the natural log of a. And if I plug in the opposite of a, well, I get that same value, right, that I'd get if I plugged in a. All right, let's imagine having to take the derivative of the natural log of the absolute value of x. And let's just do it in two parts. If x is positive, well, that's just asking us for the derivative of the natural log, which is 1 over x. It's kind of where we started this conversation. When x is less than 0, well, the absolute value of a negative number is the opposite of the value. So that's the same as taking the derivative of the opposite of x. Well, the chain rule would tell me that would be 1 over the opposite of x times minus 1, which is just 1 over x. So what this tells me is that the slope is 1 over x no matter whether my x's were positive or negative. And I can actually see that in the graph here, right? X is positive, and the slope of this tangent line would be 1 over a. Over here, x is the opposite of a, and well, that slope's going the opposite direction. M equals 1 over the x value of minus a. And all I have are slopes with opposite signs. Well, think about it. If you mirror that over, a line that used to go up from left to right is now just going down from left to right. So what I really have here is a more general derivative formula. And I can use that to establish that the antiderivative of 1 over x is officially the natural log of the absolute value of x plus c. I need the absolute value here because I'm asked for the most general antiderivative, right? And if I leave the absolute value off, I have found a function that on the positive values is an antiderivative, but it's certainly not the most general because the domain's not as big as it can be. And now if, let's say, x was replaced by kx, I could expand my antiderivative formula to include that as a possibility. And now we've seen all of the antiderivative formulas on page 283.